Good evening. I welcome you all for the first live interactive session for the course Polymers, Concepts, Properties, Uses and Sustainability. This course is taken by Professor Abhijit Deshpande of IIT Madras, and I am Kritika B, PMR scholar IIT Madras, and I will be handling this live interactive sessions where we will be solving assignment problems, practice assignment problems basically, to help you learn better and attempt your assignment questions and as well as your exam questions in a better way. So this session will contain a brief recap of your course content, your lecture content of the particular week. This will be followed by solving of practice assignment questions, which will be a combination of both conceptual and numerical questions. In numerical questions, I will also be solving the problem step by step so that you understand the problem better. Okay, and these sessions will not be just it will not be just that I only speak and discuss the problems, but it will be more interactive. So I will be asking you questions for each stage of the problem, and expecting you to answer so that it will be more interactive. There is nothing wrong, if you say a wrong answer. It is just a learning process, and I will be correcting you for the right answers. So just feel free to interact and open up and say so that the session is much more interesting. And also the session will have doubt clarification, both of the contents of the week, the lecture contents as well as the assignment questions, both your graded assignment questions. So you can ask if you have any doubt in the question, and also feel free to ask doubts in the practice assignment problems that we are solving in this session. So make best use of this platform, okay, so that you learn better. So these sessions will happen every Saturday with the same Google Meet link from 4 to 5 p.m. I request you all to come and make the best use of this session, and feel free to ask any type of questions, okay, and also make use of the forum, if you have further doubts, okay, in the NPTEL forum to ask further doubts so that your doubts gets clarified both by the professor as well as myself, okay. Please make best use of this session as well as the NPTEL forum, okay. Now, I think you would have all attempted your week 0 assignment, which is not a graded assignment as such, but it is a brief introduction, or it is kind of a preliminary assignment covering your material science, physical chemistry, thermodynamics, solid and fluid mechanics. So the aspects of which will be there in this current course as well. So it is kind of a introductory assignment. Hope you would have attempted it. Now here in this assignment session also, we will have very few questions on similar concepts, kind of a brief introduction of practice assignments as well, okay. Now let's get started on to the session. One second. Let me share my screen. One second. Entire screen. Hope you are able to see my screen. So let's get started. Okay. let's get started with the question number 1. Identify the type of deformation shown in the figure. So, is it a uniaxial tension, or is it a flexural deformation, or is it a torsional deformation, or is it a shear? Identify what type of deformation is it. So, you have, the picture shows some rod with the arrow mark. So, what kind of deformation is it? What is the change you observe in that rod? So, the answer is torsional deformation. Why is it torsional? You find the rod is being twisted. If you see the arrow mark, it shows kind of a rotation, and you could see that the rod is getting twisted. So, this type of twisting, it leads to a type of deformation called as torsional deformation. These things you would have dealt in your material science, different type of deformations and all. So, this is a torsional deformation. Okay. Now, question number 2. Which among the following are normal stress components? You know that stress is a tensor, right? And it has different components. Okay. Now, which among the following are the normal stress components? Is it sigma xy, sigma yz, sigma yy, or sigma zz? Which of these are normal stress components? So, stress is tensor. So, tensor means it has two direction associated with it. One is the direction of the normal perpendicular to the plane, and the other is the direction of the stress itself. Okay. So, based on that you have different stresses. So, which among these are normal stresses? The answer is C and D. So, you know that in normal stress, the direction of normal as well as the direction of stress, both are of the same, right? In the sense, both are of the same direction. They may be oppositely acting. The normal will be in one direction and the stress will be acting in the opposite direction to that, but both will be of the same component, or same vector, that is it will be both either xx, so it will act in the x direction, either the normal will be in positive x direction and the stress will be acting in the negative x direction, or both the normal will be in y direction and the stress will be acting in the negative y direction, or vice versa. Okay. So, here it is sigma yy and sigma zz. Okay. Now, let's move on to the third question, question number 3. So, the ideal elastic solid is defined by, ideal elastic solid is defined by certain law. So, which law it defines and what does that law says? So, is it Hooke's law that says stress is proportional to strain, or is it Newton's law of viscosity which says stress is proportional to strain rate, or is it Hooke's law which says stress is proportional to strain rate, or D, Newton's law of viscosity saying stress is proportional to strain? Which law does the ideal solid, which law defines a ideal elastic solid? So, the answer is, it is Hooke's law, and Hooke's law says that stress is proportional to strain, and where the constant of proportionality is E, elastic modulus or modulus of elasticity. So, which is the right option for a Newton's law of viscosity? And Newton's law of viscosity defines what type of material? So, the right definition of Newton's law of viscosity is stress is proportional to strain rate, and it is defined for a ideal viscous liquid. Okay. This is an additional information. You would have gone through this in your fluid mechanics. Okay. Now let's get into the question number 4. In the formula, K is equal to minus V dP by dV. K corresponds to what? Does it corresponds to shear modulus, or does it corresponds to bending modulus, or does it corresponds to bulk modulus or Young's modulus? What does K corresponds to? So here the formula is given by minus V dP by dV, where P denotes the pressure and V denotes the volume, dV denotes the change in volume. Okay. So, which modulus does it denote? So, K denotes your bulk modulus. So, here you have the volume component and change in the volume component. So, it is your bulk modulus that comes into picture. So, K denotes your bulk modulus, and this is the formula for your bulk modulus. Okay. Where there is a volumetric change, okay, compared to your initial volume. Okay. Question number 5. At freezing point, what does you observe? Does the enthalpy change due to fusion is going to 0, or is it entropy change due to fusion is 0, or is it Gibbs free energy change due to fusion is 0, or is it both A and B? What happens? This is a thermodynamics question, again from your fundamentals. So what happens? What happens at freezing point? So at freezing point, your Gibbs free energy change due to fusion is 0. So at the freezing point is nothing but your equilibrium point between your solid and liquid state. So your Gibbs free energy should be, your change in Gibbs free energy should be minimum, or that is 0. Okay. Okay. Sorry, it's question number 6. It's not question number 4. Polystyrene sulfonate is an example of, don't say it is an example of a polymer, because you find the term poly. But it is a polymer, but some special class of polymer. What does it say? So, what is polystyrene sulfonate basically? What is, first of all, polystyrene? So, you know ethylene. Ethylene is CH2 double bond CH2. Correct? So, in place of one of the H, if you replace a benzene group, it is styrene. So, you get up and n number of such styrene group. If it gets connected, if it forms a polymer called polystyrene. But what is polystyrene sulfonate? Polystyrene sulfonate is an example of polyelectrolyte. So, what is the difference between polystyrene and polystyrene sulfonate? In polystyrene sulfonate, you have a SO3H group, sulfonic acid group, okay, in the benzene ring, okay, and this sulfonic acid group, it gets ionized, dissociated to form SO3 minus. So, electrolyte you all know. Electrolyte is nothing but that gets dissociated into its ions when it is in a solution form. For example, NaCl. So, NaCl, if it is in water, it forms as Na plus and Cl minus. Okay. So, similarly, in case of polymers, we call it as polyelectrolytes, and when this polyelectrolyte is in some solvent or in a solution, in solution form, or if it is in some solvent, it gets dissociated into its ions, that is SO3H gets dissociated into SO3 minus and H plus in case of a polystyrene sulfonate. And here, what kind of interaction plays a preliminary role? It is the electrostatic interaction that plays a very preliminary role. Okay, I think you had some brief idea of all your just a brush up of your already known concepts. We will be having much more into the actual course content and your numerical problems as well as your conceptual problem in the following assignments. Okay, so don't miss. Please try to attend and make best use of this live interactive session. Okay, all the best. Thank you.